Good morning, children. So let's today start with our lesson for class 9 with motion. When we talk about motion, we know that in physics we define the states of any object in two different ways. Either it can be at rest or it can be in motion. The state of rest is considered when an object is not changing its position. Means rest is the state when there is no change in position of the object with time with respect to its surroundings. Means if in the surrounding medium, let us consider some point which is stationary one. And with respect to that fixed or stationary point, the other object or the object which we are observing is not changing its position at all. For this, you can make it more clear. Suppose you are standing on a road 5 meters or 2 meters away from some tree. You are standing on the roadside at one place where you are 2 meters away from one particular tree. So, you are at rest for that tree as a reference point. Second thing, suppose a person now crosses from nearby and he sees that when he is crossing in the forward direction, you seem to appear moving in the backward direction. So for him, you are in motion because with respect to that second observer, your position is changing with the passage of time. So when we talk about rest is that state of an object where there is no change in position with time with respect to reference point. But when we talk about motion, motion refers to that state of an object when the position of object changes with respect to the reference point with the passage of time. And rest and motion, like if I consider, suppose you might have heard of people saying that she is taller or he is shorter. So how is it that we compare people on the height basis? Obviously, they have chosen some or the other reference level, and with respect to that reference level only you can tell whether the person is taller or shorter. So this reference level is required for the two states as well. Here, states of rest and motion are also called as relative terms. Now, what does this relative term means? Relative terms mean that any object cannot be in the state of absolute rest or absolute motion. It is always that it will have the state of rest or of motion with respect to the reference point. Means if we are changing the observer or if we are changing our frame, then the state may also undergo a change. Let me make it more clear by taking an example. Suppose you are person A. You have gone to see two of your friends B and C. Both have boarded a bus or a train and they are inside it. You are standing out of that particular bus or the train. Now that bus or train starts to move. Both are sitting, both B and C, they are sitting inside it. You are standing out and it starts to move. So the state of B is at rest for C. Means if C is observing, he will say that B is in the state of rest. But on the other hand, if you ask A will say no, B is in motion. Means what? B is having both the states, rest and motion at the same time. But it varies that what is the reference level we have chosen. This C is the reference level when we are saying B is at rest. And A is the reference point or the observation point or the observer who is viewing that B is in motion. That is why here the same object B is having rest or motion state depending on the reference point or the observer. Same way, let me explain it through another example. Suppose you are sitting in your room, sitting at one place only, and a person who's standing nearby you tells you that you are in the state of rest. He is the observer, he is observing you. Case 2, at the same moment, an astronaut from moon views you. Because you are there on the earth and we know earth is in continuous motion. Now due to that continuous motion, the person who is viewing you from the moon side, you will seem to appear in motion along with earth. So for him, your state is motion. And for the person standing next to you, the state is rest. means you are having both the states at the same time, but that varies from observer's point. Means if we choose different reference levels, the state of the object also changes. So I hope that this topic of motion and rest as relative terms is now clear to you. Next we'll take up it the other time. So now I told you that rest and motion, they are relative terms. Now coming on to a basic concept of physics. See, when we are talking about physics, we know there are many of the quantities which we measure. There are different quantities. Right from your very early years, people keep on asking you, what's your age, beta? So what is that age? That's a measurable quantity. Suppose you are going to market to buy something, maybe some veggies or some fruits. There also you need to ask or to tell the shopkeeper, please give 1 dozen of this thing, or suppose please give 5 kgs of something. So what is that 5 kg, 2 dozens, where you are relating to some kind of a measurable quantity. There in physics, all those measurable quantities are referred to as physical quantities. We measure the quantities, and all those quantities which can be measured, they are termed as physical quantities, which broadly are classified under 2 categories. One is the scalars and the other one is the vectors. Now when we talk about scalars, what do you mean by scalar? Scalar refers to those quantities, those physical quantities which are completely described by magnitude only. Means what? Magnitude refers to that there will be a numeric value. Along with numeric value, there will be a unit associated to it. For an example, if I ask you for your age, you say 15 years, 16 years, like that, where 15 becomes the numeric value, years become its unit. So numeric value and unit, that makes up the whole thing, that is magnitude. For your age part, you are nowhere concerned about telling age in which particular direction. So it's only that magnitude is completely defining it. All those quantities which have magnitude and are completely defined by magnitude only, they are referred to as scalar quantities or scalars. Now coming on to vectors, there are certain quantities in which it is very much important to add on a direction along with the magnitude part. When we add a direction to the magnitude, then those quantities are termed as vector quantities, or simply they are called as vectors. Generally, the method of representing a vector is different from that of a scalar. When we represent a scalar and a vector, to represent a scalar, we need only, suppose object is moving from A to B, we can represent it as A, B. But to represent this thing, that the object is moving from A and it is reaching B as a vector quantity, means as a displacement form, we need to write it as A, B with an arrow mark over it. Arrow mark over AB shows that the object has started from A and is going towards B. So AB without arrow mark is a scalar quantity, and AB with the arrow mark refers to the vector quantity. Let's make it more clear by taking one example. I have taken a situation where I have marked the distances on the picture itself. From A point, the distance up to C is 7 centimeters. CB is 3 centimeters. AB is 10 centimeters. Now the question is, we have to find out distance and displacement for different positions. Position 1 is when the object is moving from A to point B. Means from A to point B. Obviously clear, it's moving along the same straight line covering the total path length. Therefore, distance AB becomes equal to 7 plus 3. That is 10 units, centimeters. For the same, if I have to find out displacement, because there was no change in the direction, so for straight line motion, if there is no change in direction, distance and displacement would be same, because displacement refers to that difference of final and initial position. It is referred to as, if you join the final position to that of the initial position from where the point started, that straight line, the shortest path length we can say, that shortest path length gives us displacement. So here AB displacement, because we are talking of, so from A to point B, Displacement is 7 plus 3, again 10 centimeters. Let's take up second case where the object is moving from A to point C. From A, it is moving to point C via B, I have written. It means from A, first it moved to B and then it took a U-turn and came back and stopped at point C. So we have AC as the distance covered, which is equal to, because it has moved through B, so it will be equal to 7 plus 3 and then minus 3 units, which it has moved in the opposite direction, thereby making it 7 centimeters. The distance covered, if I am right here, then because it was a distance covered is the total path length. So I don't need to take it as minus sign. It will also get added up only. I can't consider the direction change here. Reason being, I am talking about distance. So distance covered is total path length, 7 plus 3 and then 3 more, 13 centimeters. Whereas when it comes to displacement, means I will be joining final and initial position with the help of a straight line. Joining final and initial position with a straight line gives me this length only. So that displacement AC is equal to this much distance, which is 7 centimeter. And how come it is coming out 7? We have 7 plus 3 because both were towards the same side. Whenever there is a direction change, now because when it reached B पर आकर इसने अपनी डायरेक्शन चेंज की. सो व्हेन इट रीच्ड बी, उसके बाद क्या किया इसने, इट मूव्ड इन द ऑपोजिट डायरेक्शन. सो वी हैव टेकन अ माइनस हियर और वापस कितना गया, 3 यूनिट्स, एंड दैट्स हाउ वी गेट इट इक्वल टू 7 सेंटीमीटर एज द डिस्प्लेसमेंट. नाउ टेकिंग अप केस 3 वेयर ऑब्जेक्ट इज मूविंग फ्रॉम ए टू पॉइंट सी. A to C directly means when it is moving towards this side, it has stopped at point C itself. So distance AC is equal to 7 centimeters and displacement AC in this case will be equal to again 7 centimeters. Now let's take up one more case. Case is, or the situation is, that object is moving from A, it goes to B, from B it moves to C and then comes back to A. Means the motion is like from A till end it is going, then from B, this was A, this is B, then from B it is coming to C, taking a little halt and then continuing to move to A. So it started from A, finally it reached on to the same position. This is initial position and this itself is the final position also. So how much is the distance covered? When it was moving from A to B, it covered a total of 10 centimeters. Plus, when it was moving from, this is AB is 10 centimeters, then from B to C it has covered 3 centimeters and from C to A it has covered again 7 centimeters. But these, I am talking of distances, although it's moving in the opposite direction, but the total distance from A to B to C to A will be the sum total of this, means 20 centimeters is the distance covered. While talking about displacement now, see, मैंने अभी बताया आपको shortest distance, ऑब्जेक्ट जहां पहुंचा और जहां से शुरू हुआ था, उन दोनों पॉइंट्स को if you join them directly, then that shortest distance becomes the displacement. यहाँ A से शुरू हुआ, A पे ही वापस आ गया, इसका मतलब क्या हुआ, ऑब्जेक्ट अपनी जगह से डिस्प्लेस नहीं हुआ है. ऑल्दो इट हैज कवर्ड सम डिस्टेंस, उसने 20 सेंटीमीटर डिस्टेंस कवर किया मगर फाइनली अपनी पोजीशन पे आ गया. सो डिस्प्लेसमेंट इन दिस केस A to B to C to A back, it gives us displacement equals to 0. I hope this is clear. So here the displacement becomes equal to 0.